Yeah. Yeah. So they say university makes students. Here, students make university. So with the slogan of Think Big, I, Himanshu Kaushik, would like to welcome you all in today's webinar on Introduction, Mechanism, Issues, and Benefits of Electromagnetic Induction. And I hope that you all are safe, sound, happy, and healthy at wherever you're taking this webinar from. So before we move on and learn a lot through the session today, we have our expert here with us. So I shall introduce you to our expert. We have Dr. Prashant Kumar Chaudhary, an assistant professor, School of Electronics, Electrical Engineering, School of Polytechnic, lovely professional university here with us. He is an accomplished academician with more than 23 years of teaching experience in different universities and institutions, out of which over 14 years was of teaching core subject of electrical engineering only. He has done his PhD from Chhattisgarh Swami Vivekanand University and has his interests in the field of electrical machines, electrical power systems, instrumentation and control, automation, and artificial intelligence. So, sir, it is a pleasure for us to be here, to be able to listen you in the webinar. And now I request you to please take over the screen.
Thank you, Himanshu ma'am. A very good evening to all the students present here. I'm Dr. Prashant Chaudhary from School of Polytechnic, Electrical and Electronics Division. I'll be talking here on the topic electromagnetic induction, which is a very prime topic in our electrical engineering. Students, as we know, energy is very important for all of us. In our day-to-day activity, in every day, we need energy. Electricity is one of the very important form of energy. Okay. The topic electromagnetic induction is directly connected with the electricity generation, what we need every day. Okay. So the amount of electricity, what we are using, what we consume every day. Okay. Most of the electricity are being generated because of this concept, this phenomena, what is called electromagnetic induction. Okay, it's not only about the generation of electricity, but transmission of electricity. There also we have this concept directly involved. And if I talk after this generation and transmission, okay, in consumption also, we have this concept directly involved. So in brief, I must tell you, this concept, this electromagnetic induction principle is involved in generation as well as in transmission as well as in consumption of electrical energy in our day-to-day activity, in our industrial requirement, everywhere. Okay. As you people must have come across during your 10th and 12th. Okay, so just wait. I'll be talking from the very basics here to make you understand this concept. Very attractive, very interesting. Okay, so my content of discussion today is here. What is magnetism? What is this electromagnetism? what is exactly this concept of electromagnetic induction. Okay, so you'll come to know meaning of electromagnetic induction here in a better way as compared to your school contents. Okay. Also, one of my very important target today here is to make you aware of the various applications, various utilities which are around us. Okay. To make you aware of such devices, such equipments, such applications, okay, in which this concept of electromagnetic induction is involved. This will be my second target here. In fact, I'm going to show you some of the applications, some of the devices, okay, which are very in the close vicinity of we people. Okay, you might not be aware, okay, in this device, the concept of electromagnetic induction is being used, being utilized. So I'm going to show you a few examples. Okay, so that will make you more interesting, more curious about this concept. And after this, I'm going to talk what additional things you'll come to know when you join this UZ program or diploma program in our university or in any other university of our country. Okay, so I'm just starting here with some of the very common devices, common equipments I'm going to show you. Okay. I'll just wait 1 minute. I hope screen is visible to all of you. So, dear students, here this is the most common device what we see in our close vicinity everywhere. This is a transformer. Okay, and this comes in the category of essential devices. Whether transformer, this is a big size, whether this is of small size, whether this is used in electronic applications or whatever uh, applications we do have in industry, this device utilizes the concept of electromagnetic induction. And in your 10th or 12th, also you must have come across some concepts like Faraday's law of electromagnetic induction. Okay, so this is your transformer, very essential device. Without transformer, you cannot have desired voltage level in your house. Okay, we generally generate electricity at a very high level of voltage, but we consume electricity at very lower level. You must be knowing 220 volt, 230 volt. Okay, so here the concept of electromagnetic induction is involved. Here, this is the next device, which is electrical generator. As I told you previously also, we cannot think of electricity if we don't have this process, this concept, Faraday's law of electromagnetic induction. So generator uses the concept of electromagnetic induction to convert a particular amount of mechanical energy into electrical energy. Okay. Whether this electricity is being used in our household applications or in industry, everywhere, If there is generator, this is using somewhere the concepts of electromagnetic induction. If I see a very common device in our kitchen, you must be aware of induction cooktops. Okay, this also utilizes electromagnetic induction concept to directly heat pots and pans. Okay, we are using this concept here. We are this is since last 10 years, this concept is being in use in our country. We are using this electromagnetic induction cooktops. If I see some industrial aspect, so we have induction furnaces also, where metals are being melted with the help of electromagnetic induction concept. So you can imagine the power what this concept is having, electromagnetic induction. Okay, it can melt metals also. Okay. If I come to the latest developments, what we have in these years, these 5 years, recent 5 years. So I think everyone must be aware of wireless charging concept. Okay. There also somewhere we are using this concept, induction chargers. Okay. This is for transferring power between one circuit to another circuit without using conduction mechanism. Okay, you can transfer power from one point to another point, from one circuit to another circuit, from one device to another device with the concept of conduction. Okay, that is a conventional mechanism. Okay, but if you think to transfer the things, the energy, the power, okay, without using some cable, okay, without having some conduction mechanism, media. So one of the concept what is being used in this wireless power transfer is this induction charging concept. Okay, whether I'm charging a vehicle, whether I'm charging, okay, some small devices like toothbrush. Okay, if you have to do the things without using power, so this concept is in great use. Like one more example, what we find in our house, this is wireless speaker. Here also, we are using this concept of electromagnetic induction somewhere inside. If you see the circuitry, if you open this box, okay, so somewhere you're finding some circuit which is doing this job. Electromagnetic induction concept must be involved somewhere. Okay, sensors, we all know the use of sensors. Okay, nowadays sensors are very important, whether this is industry, whether this is our smart house, smart home. Okay, sensors plays very important role. So in sensors also we find this concept, electromagnetic induction is involved somewhere. Okay, when you join these courses, engineering courses, so you'll come across the more details on these things, how these sensors are actually working. Where is this electromagnetic induction? Okay, concept is there. Some MAGLAB system, you must be knowing strains moving with the concept of magnetism. So here also you'll find electromagnetic induction concept is involved. Okay, so actually the train is not on physically not on the on the track. Okay, it's above. It is you know it actually swings. Okay, it actually shifts on the track. Okay, it's not in the physical contact with the track. So this is possible because of the concept of magnetism and this electromagnetic induction. Okay. Some induction dryers, some voltage regulators, okay, like heating system. Also, you'll be finding this concept electromagnetic induction is utilized. Inductive lighting also one of, okay, you must have come across such type of device somewhere in the market, in the shopping mall, or in some big buildings. Okay, so my purpose was very simple to make you aware. This concept, electromagnetic induction, is not a small concept, it's a very big concept. Okay, and it is the basis of, you know, most of the
Um, sir, sir, am I audible? Sir, am I audible? I think
yes,
there is,
yes.
yes, I think there is some internet lag. Your voice is not audible properly.
This is not clear.
No, 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 sir, you're not audible properly, sir. Like your voice, I mean, we cannot hear you proper.
Okay. So, sorry for interruption. This is technical interruption. Okay. Okay. So, I tried to make you aware of the devices or the mechanism or the equipments what we have around us, where this concept electromagnetic induction is actually already functioning. Okay, this is already functioning. So let us talk now on what exactly this concept of electromagnetic induction is. Okay, what exactly happens here when we say electromagnetic induction or when we say Faraday's law. Okay, so this electromagnetic induction is exactly a process in which a changing magnetic field induces a particular amount of electric current in a conductor. Okay. I repeat this. This is the most important point as a student you need to remember. Electromagnetic induction is a concept, is a process in which, because of change in magnetic flux linkage, okay, you get electricity through a conductor. Generally, what we know, if I ask you how do you make electromagnet, so you'll be saying, sir, we will take one coil, we will pass electric current through it, and so we are going to get an electromagnet, which is different from permanent magnet. Okay. But we have another section of another aspect of another dimension of electromagnetism here. Okay, in which a magnetic field actually produces current. Okay. What was in the previous? Current was producing electromagnetic field. Current was producing magnetic field. But what I'm saying here, this is electromagnetic, this is a magnetic field which is going to produce one electric current. Okay, and this is the basis of all the transformers, all the generators, okay, and all the devices what we talked as an example. Okay, so always remember this concept. We have two dimensions when we say electromagnetism. One is magnetism to electricity, another is electricity to magnetism. Okay, so here we are talking magnetism to electricity. Okay, changing magnetic field induces electric current. Okay, very important to remember. And this was actually derived, not derived, discovered. Okay, accidentally while doing some experiment. This was found by Michael Faraday in 19th century. And since then, we are using this concept. So you can imagine how old this technology is. Okay. So the key idea is electromagnetic induction is that concept through which a magnetic field can create an electric field, and this electric field is going to generate electric current. So this sequence of event you need to keep in mind. Okay, magnetic field will be producing one electric field, which will lead to the generation of electric current if the path is closed. Okay, this is the last punch, the last statement. If the path is closed is very important because current cannot pass through a broken media. Okay, there is always a medium required for flow of current. So this concept we know in the form of Faraday's law of electromagnetic induction or Maxwell's equations. Okay. So here, once again, as a summary, I am giving you a simplified explanation of the process of electromagnetic induction. What are the key points? What are the major things you need to remember? So first thing you need to remember is changing magnetic field. Okay, you cannot have things happening with constant magnetic field. Okay, I told you in the previous slide, electromagnetic induction is a process in which changing magnetic field, okay, changing magnetic field is most important. So we cannot have with there should be something, some change must be involved. Okay, suppose if this is not magnetic field is not changing, then somewhere something associated in the equipment must be changing. Okay, for example, conductor must be in dynamics. Okay, if I talk, you must be knowing dynamo principle in your schools, from your schools. Okay, so you may be asking, sir, magnet there is fixed, magnetic intensity there is fixed. Okay, but you're saying changing magnetic field. So see carefully, you must be finding if field is constant, if magnetic field is constant, so there is some dynamics involved, with the conductor. Okay. So magnetic flux linkage is exactly the term I should use, which should be variable. Okay. The second thing here is what happens next. So this is we get electric field induced in the conductor. Okay. You can measure this electric field, okay, in the terms of potential with the help of some potential measuring devices like voltmeter or multimeter. You can do this experiment in your, if you have some facility. Okay, you can check. This really happens. Okay, you'll get reading in the meters. Okay, what next happens is induced electric current. So because of change in magnetic field or linkage, okay, you have electric field induced. So electric current is getting induced, the path is closed. Okay, and this all happenings are explained by two laws. One is called Faraday's law, that is Lenz's law. Okay, so the Faraday's law says the magnitude of the induced electromotive force, EMF, okay, is proportional to the rate of change of magnetic flux through the conductor. We must be aware of this thing, how much is things getting produced, how much EMF getting produced, how much current is getting produced. So who will tell us how much is getting produced? So Faraday's law tells us the magnitude of induced electromotive force. Okay, and what is this? What is the statement of this is the magnitude is proportional to the rate of change of magnetic flux through the conductor. Okay, and you must have come across some negative sign many times in the equation. This is the equation. I hope you must be a little bit aware of this. Okay, E is equal to minus n delta phi upon delta t. So Faraday's law tells this is the magnitude, okay, which you'll be getting while generating electricity. Okay, and this minus sign, okay, we call this Lenge's law. Okay, so this Lenge's law is nothing but a very important consequence of Faraday's law. And what this states, the induced current will flow in a direction that opposes the change in magnetic field causing it. Okay, this very important concept here. Okay, whenever this current is getting induced, remember always Lenge's law will be applicable everywhere, whatever the system we talk, whatever the equipment we talk. Okay, so what it says, what is the statement, what is the concept here, what is the final outcome of this electromagnetic induction is current. So there is a force which is going to be acting opposing this induced current, cause of induced current. Okay, so what was the very first cause of inducing current is change in magnetic field. So Lenge's law says it is going to oppose this change in magnetic field. Okay, now somebody may be thinking, from where this came? Why this Lenge's law? Okay, so this is in the sense of fulfilling the energy balance law, that is conservation of energy. Okay, so Lenge's law makes the energy balanced here whenever we get EMF or current getting induced in the circuit, in the conductor, in the wire. Okay, and this is here mathematical expression of this entire concept. Okay. Now, I think we talked sufficient on this concept, electromagnetic induction. Okay. Now, I'm going to talk what further you'll be doing when you join the engineering course here. Okay, in your curriculum, where you're going to see this topic again. Okay, in your engineering curriculum, I'll be talking on that. Okay, with the help of some another PPT here. So I'm going to change the PPT first, and then I'll come to this point. What further and where we'll see this topic, okay, for your engineering curriculum. Just wait one. Actually, sorry, I had to change my system, so that PPT is not here. I'm just going to tell you verbally here where you'll be finding these contents further. Okay.
Sir,
Yes, yes, yes,
yeah.
ma'am.
So is there any problem that's happening?
Actually, one more PPT was there that is not available in this system right now.
Okay, okay, no issue, sir. Uh, I think you're stuck again.
Okay. Am I audible, ma'am?
Yes, sir, you're audible,
Okay.
sir.
So, students, I'm here bringing you back, putting your attention on some of the very common devices what we have. That is transformer, which utilizes this concept electromagnetic induction. I'm going to talk in some more detail. Okay. So you can see this diagram here. The bottom left side, bottom. So you can see some structure. Okay, a magnetic core is there. We call it transformer core. Okay, and you can see two wires, one in here red color, another in here blue color. Okay, so we call it high voltage winding, we call it low voltage winding. The blue one, what you see here, is called low voltage winding. Okay, here this is high voltage winding. Okay, you know what happens in transformer? You might be thinking how this electromagnetic induction concept is involved. So you must be able to visualize here. We have some sufficient number of turns here in this red color in this high voltage winding. Okay. So can anybody count this number? I think it must be around 15 here as per this diagram. Okay. So we call it high voltage winding. Okay. Listen carefully. We call it high voltage winding. Okay. Similarly, if I count here, this blue wire, okay, blue winding, which is on the right hand side. So here also you can find 7-8 turns. Okay, so definitely 7 or 8 is less than 15. You know, so this is called low voltage winding. Now, whenever you see a transformer, whether this is being used in your house or in your society or in your electronic gadget or in your mobile charger or in your TV, now you have to imagine there, okay, we are using transformer, okay, in this device. And in transformer, we have two basic component. One is called core and another component is called winding. Winding can be two types, high voltage winding, low voltage winding. Okay. Now, you know, load is connected with this, as per this diagram, if I say load is connected on the right hand side. So load will be connected here on the low voltage winding. Okay. And if there is some load, so there must be some supply. Otherwise, there is no meaning of load. There is no meaning of supply. Okay. So supply is here on right left hand side. It is connected with the high voltage winding. So in this case, we generally say this left side is primary winding also, and right hand side is secondary winding also. You must be knowing from your schools, there is a primary winding, there is a secondary winding. Okay. So, we give supply with this coil, with this primary winding. Okay, we connect supply here. Okay, and we get electricity from here. This is secondary side. Okay. Do you find any direct connection of primary winding circuit with the secondary winding circuit? If I see this diagram, the answer must be no. Okay, we don't have any direct connection between this red wire and this blue wire. Okay, between this red winding and this blue winding, we don't have direct electrical connection. Okay, but we have a magnetic connection. Okay, but we have a magnetic connection here with the help of this core. Okay, so power what you have applied in the primary side is going to be shifted to the secondary side, utilizing the concept of electromagnetic induction. Okay, by utilizing the concept of electromagnetic induction, we are able to produce power here. Okay, at our desired voltage level. At our desired voltage level. Okay, so this is involving the concept of this electromagnetic induction here, right? And the EMF, what we are going to get induced in this blue coil, blue winding. Okay. If EMF we are getting with because of this electromagnetic induction concept. Okay, so we call it statically induced EMF. We call it statically induced EMF. Okay, there is one more kind of EMF, what we say dynamically induced EMF or dynamic EMF. What we have in the cases of rotating electrical machines. Okay, transformer comes in the category of static electric machines. Okay, things are stationary here. Okay, in this transformer, we don't have moving components. Okay, here the flux is changing. Okay, flux is changing. In the case of transformer, flux is varying. If I say rotating machines, so there is some component where which is stationary, and there is some component which is rotating. Okay, in the case of transformer, we don't have anything in general or rotating component. Okay, flux is changing here. Okay. If I talk DC machines, okay, like the DC generator, we do have DC generators. Okay. Nowadays, we are using AC generators in most of the locations. Okay, but few years back, around 25, 30 years back, DC generation was also playing a very dominant role in electricity generation. Okay. Still, we are using DC generators in our many applications, but the applications are limited as compared to the era, which was 25 years back. Okay, by the way, if I talk DC generation, so there you'll be finding we are not changing flux. Okay, just remember the dynamo principle. Okay, I can show you some diagram. Hopefully, it must be here. There is some generator. Yes. So I think you must be remembering such type of diagram. You must have come across in your school books also. And this diagram is exactly not DC generation. This is exactly AC generation. Okay. So you can see the diagram is having a permanent magnet here, north polarity, south polarity here. So magnetism is fixed here. The magnetic intensity is fixed here. Okay, we are not changing magnetic field. Then what we are changing? We are changing this conductor position with respect of this magnetic flux. Okay, so actually conductor here is in movement. Conductor is moving. Conductor is dynamic. Okay, with the help of diesel engine or diesel power or the steam powered or the any other mechanism of mechanical power. Okay, if someone asks you how we generate electricity, so we keep rotating this conductor, we keep rotating this conductor. Okay, and because of this rotation, the flux linking is getting changing. Okay, the flux linking is getting changing. Magnetic field is constant here. Okay, so the conductor is under dynamics. And here the EMF gets induced, what is called dynamically induced EMF, dynamic EMF. Okay, this is also happening because of this electromagnetic induction concept. Okay, what we say Faraday's law. Okay, so students, Faraday's law, and you can remember this statement. Faraday's law is the basis of almost every electrical devices we are using in our requirement, in our day-to-day requirement. Okay, whatever most of the devices will see, which is concerned with electrical, okay, Faraday's law, you'll be finding applicable, okay, is involved. Here also, if I see our next device like this induction cooktops, okay, concept of electromagnetic induction is used. Many people will be wondering how this is possible, how this is happening. Okay. Simple concept. A changing magnetic field induces electric current. In the cookware, okay, put your attention on cookware, which generates heat due to resistance of the material. Okay, so the cookware, what you are using, it is having sufficient resistance. Okay, so we are generating heat by passing through current through this material. Okay, we don't have direct electrical connection. So this gives you a safety aspect while cooking. Okay, as well as you can have this cooktops of different capacities, like 800 watt, like 1000 watt, like 1500 watt also, or even higher as per your requirement. So, innovation always gives you flexibility. 10 years back, this device was not available, but now this is available, okay, with greater flexibility. We are using the concept of electromagnetic induction. Okay, and see this diagram. This is wireless charging disk. Okay. 10 years back, if someone was talking like this wireless charging disk, so this was a matter of joke, but now this is available. We are using this with the help of this concept. Okay, so friends, I think we talked sufficiently on this topic, and you can give me your questions. You can put your questions if there is some mechanism to put your question. Okay, so see you in your next class. Thank you. Thank
So
you.
yeah, thank you so much, sir, for giving this presentation, insightful presentation, and for coming in, for giving your time, experience, and knowledge to all of us, to the students and me especially. Thank you so much, sir. And sir, we have a lot of questions that have come from the students. So with your permission, can I take them up?
Yes, yes, please.
Sir, this is a very straightforward question. It came from Ishani Hilal, and it says, sir, what is self-induction? Please explain.
See, what is the name of the student?
Ishani Hilal.
Okay, so Mr.
I think, sir, you stuck again.
The same concept here. Okay, a transformer. You can see two windings here. Okay. You can see two windings here. One is pink color, sorry, red color. Another is, this blue color. So, see, I give supply in this primary winding, which is of red color. Okay, so this is going to produce a flux. This flux is going to interact with this blue winding. Okay. And EMF is getting induced in this blue winding. So this is what we say mutual induction.
Okay, sir.
This is what we say mutual induction. So we are getting energy because of some flux created by some another circuit. But this flux linkage with its own coil also, means red coil also. Okay. The flux you can see here marked with this green line here on the core, transformer core. So this is interacting with this blue winding, secondary winding. Okay, so here EMF will be induced with the concept of mutual induction. Okay, and the same flux is going to produce an EMF in its own winding also. Okay, so this is what you can say self-induction is happening.
Yeah.
Okay.
Yeah. So thank you so much, sir.
Oh, okay.
Yeah, and sir, we have another question. It is from Radha Sharma, and says, how is a magnetic induction used in everyday's life, sir?
This is what I'm trying to convince you, trying to make you understand from the beginning. In fact, I talked about the topic later on, but I started with the concept of application only.
Yes.
Yes, this transformer is in the very close vicinity of you. If you want to see a big size device, which is utilizing this electromagnetic induction concept. Okay, if you visit your kitchen, you'll see kitchen system,
Yes.
induction cooking system.
Yeah.
Okay, if you see the new trends, so you must be finding wireless charging. Okay,
Yeah.
for your mobile phone, for your laptop, for your some another gadgets. Okay, like toothbrush. Okay, many where we are finding the application of this concept of electromagnetic induction. Okay.
Yeah. Thank you, sir. And I hope, Radha, you must have got the answer you wanted of the query that you have given to us. Sir, with this, we have our last query, and it is from Viraha Sharma. So this question read, are there any limitations also in electromagnetic induced devices?
Yes, definitely we have many limitations because when we say inductance now, so size actually matters. Uh, size is a very big factor. Many circuits we avoid using inductors, okay, in the circuit because of bulky size. This is one big thing you can say. Okay, if I talk some high capacity devices, you need to get some proper cooling mechanism, 24-hour services, and that's why you must, if you see one open tank transformer, you'll be finding cooling oil there. Okay, so like every engineering aspects, this also has its own justified limitations. Okay.
Yeah, thank you, sir. And now I would like to ask anyone who has any of the queries or any thought, any question, you can post in Q&A box or chat box. And so meanwhile, I would take your permission to show them, a little about the site itself, because we've been getting a lot of admission queries.
Okay.
Okay, so to all the students who had given us about the admission, I mean, who were asking us about this admission, how you can take admission. So this is one stop solution for that, and this is our site that is called lpu.in. So before we move on to admission queries, I would want to tell you, since we are attending this webinar here, so we have different webinars that are coming up. Okay, and how you can reach that particular page on our website is simply click on lpu.in, and this will be the interface that will come in front of you. Now you have to click on this admissions, and once you click on the admission, at the left hand side you will be seeing this LPU's Edu-Fair webinars page. So you click on that, and there are a whole lot of webinars that are already planned, so you can just enroll yourself in whichever you want. Okay, and these are like, all the webinars are free for you to register. You can register in whichever webinar you want, however, and how much ever webinars you want. Okay, now we're moving back to our admission queries. So since we're talking a lot about how you take admission, I will be basically giving you a glance of it. So once I click on the admissions here, you can see a whole lot of programs right here. After 12th, after graduation, 10th, after post-graduation, online, distance, intern, diploma, etc. So for example, I would take this, like I'll assume that you are somebody who's done your 10th or 12th grade. Let's say you're done your 10th grade and you want to take part. So after 12th, it's very usual. I mean, you go to after 12th, right? But after 10th, it's a little unusual for students to go to engineering. Why? Because you get the diploma there, right? So once I clicked on after 10th there, so there are a whole lot of disciplines in that particular program that are given to you. You can see here engineering, architecture, management, design, MLT, fashion design, etc. So now let's just click on the engineering here. And once I click on the engineering, we have all the streams that are offered under that particular discipline. You can just check it out. Electronics and communication, electrical engineering, civil, mechanical, computer science, etc. So let's just click on electrical engineering, and here we can see diploma engineering, electrical engineering. So once I click on any of the program, you will be getting all these options, and hence all the knowledge and all the things that you would want to know about a certain program would be given to you on this page itself. So in next 1 minute, I'll be briefing them all. So this program details basically gives you the eligibility, whether you are eligible for particular course or not. You can check it from the program details. And moving to highlight option. So this highlight option basically gives you all what students are achieving in that particular course, what rankings are there in university in context with the course that you are searching for. And moving to this curriculum part, which actually gives you all the topics you will be studying in your 2, 3, 4 years course, and in which term you're gonna study what topic. This is already given beforehand, even before you take admission in here. So I think that would be helping you to make a disciplined decision as to whether you want to proceed with the course or not. So now coming up to the fee part, so simply click on the fee here, and once you click on the fee, we have you can see 50,000 per semester. That is our fee. But again, this is not something that our students do pay. Why? Because students get a lot of scholarships. And on what basis? These are the basis. You can see we have 3 categories of scholarships, category 1, 2, and 3. And based on that, you can get up to 58% of that scholarship. So you simply need to go to the fee section and check the eligibility for that particular scholarship. Okay, and we have other scholarships as well, so you can just check it out. We have other scholarships based on innovation, startup entrepreneurship, sports, cultural, art, co-curricular activities, or if you are a topper in any education board, you will be getting some scholarship here. And we do provide some financial aid as well. So if you are eligible, so kindly apply for the scholarship and take admission here. Now I will be telling you the most important thing is 15th June will be the last date of admission. So I think it's just tomorrow or day after tomorrow. So you need to be very much eager to start applying for the course, right? And how you can apply is from here. You simply click on the apply. Just a moment. You simply click on this apply now option. And once you click on this apply now option, this will be the interface that will be given to you. So here you can register. There are some bare minimum requirements, and you register from here. And after that, you'll be given your dashboard. And from there, you can simply apply for the course or the test. Now, I hope that I've given you a little insight as to how you can apply for a particular course or not. Now, if you have any other questions, you can directly schedule a call. You can WhatsApp us or have a live video counseling session as well with our esteemed counselors present here. Or last but not the least are the numbers. You can write it down or take a screenshot of it. These are the numbers. You call on them, and our counselors will be here to resolve your queries if you have any. So you can call on these number directly. And now I think I've given you a brief idea as to how you can take admission and what is the process going to be. And with this, I would want to ask the permission from our expert here to wrap this webinar up, sir. Can I?
Oh, sure.
Thank you, sir. So thank you so much, sir, for coming in, for giving your time. And thank you so much for all the participants as well for coming in and staying here. And the questions that you've given us are really appreciated. So until next webinar, stay safe, stay healthy, and thank you so much for joining in.